Hello students, now we are going to learn the chapter 5 exponents and powers. Before that we are going to learn some basic definition, that is power, exponent and base. Power, exponent and base. So first, what is mean by power? An expression represents repeated multiplication of the same factor. Repeated multiplication of the same factor is called power. Fine. For example, 16, that is equal to 2 into 2 into 2 into 2, that is equal to 2 power 4. This 2 power 4 is called power. Generally, the power has two components. For example, this is a power. One is base, another one is exponent. Here, this 2 is called base. The 4 is called exponent. We know that 2 is power 4 is called power. Now, one example. Write 64 in exponential form and identify base and exponent. Fine. Solution. So write 64 in exponential form. Exponential form is nothing but, suppose 16 means 2 power 4. This is the exponential form. So now I am going to write first 64 in exponential form. So before we write the exponential form, I am going to split the 64 using by prime number. So I am going to split the 64, 2 into 32. Again I split, because here 2 is a prime, so no problem. I divide 32, 2 into 16. So again 16 is not a prime number, so again I split 2 into 8. Here 2 is prime, again I split 8, 2 into 4. Again I split the 4, 2 into 2. So that is 64 is nothing but 2 into 2 into 2 into 2 into 2 into 2, that is equal to 2 power 6. Actually this is called power. Here base equal to 2, exponent equal to 6. That's all. Now some important note regarding this chapter. Note. Actually first note is, before that, let A be any integer. Let A be any integer. Then, actually this is not first note. Then the first note is minus A power odd number. Minus A power odd number equal to minus A power odd number. That is correct. So fine. Minus A, suppose base is minus A, the exponent is odd number, means the answer is minus A power odd number. Second note, minus A power even number, that is equal to A power even number. Third note, minus 1 power odd number, that is equal to minus 1. Suppose minus 1 power even number, that is equal to plus 1. Fine. Our next topic is numbers as exponents, numbers as exponents of their prime factors, their prime factors. So for example, express 432 as product of powers of their prime factors. I am going to split the 432 in terms of prime factors. I divide the 432, that is solution. So I divide by using the prime number from 2, that is 216. Again I divide the 216 by 2, 108. Again I divide the 108, 2 into 54. Again I divide the 54, 2 into 27. Again I divide the 27 by 3 because not divisible, 3 into 9. So 3 into 3. So here these are prime numbers, 3, 4. So 432 is nothing but how many 2? 1, 2, 3, 4. So 2 power 4 into how many 3? 1, 2, 3. That is 3 power 3. This is the expression of the 432 as product of prime factor. Okay, fine. Some additional examples. Example 1, which is greater, 2 power 3 or 3 power 2. First we expand the exponential form into expanded form. So 2 power 3 is nothing but 2 into 2 into 2. So that is equal to 8. 3 power 2 is nothing but 3 into 3. That is equal to 9. So very clear. 2 power 3 and 3 power 2 is greater. The next example is express 32 as power of 2. So I am going to explain the 32 as power of 2 mean I am going to split the 32 as per prime factor, 2 into 16, 2 into 8, 2 into 4, then 2 into 2, that is equal to nothing but 36 equal to 2 power 5. These are the powers of 2.